At this point, we will move straight into our next panel, which is moderated by Shannon Hood. Shannon is an agent associate with University of Maryland Center for Environmental Science and Maryland Sea Grant Extension. Her research focuses on improving production practices to increase operational efficiency on oyster aquaculture farms. Growers in Maryland may also know her because she operates the demonstration oyster farm at the Horn Point Lab and conducts research on topics identified with and by industry members. Shannon also worked with the Maryland Shellfish Growers Network to develop a curriculum for public education and outreach to waterfront property owners to educate them on the myths and facts about oyster aquaculture. So I'd like to turn it over now to Shannon to introduce our next panel on technology and innovation in oyster aquaculture.
All right, thanks, Allison. And thanks to the morning panel for a great session to kick off the day. Thanks everyone in the audience for joining this session entitled New Horizons, Technology and Innovation in Shellfish Aquaculture. I'd like to thank the conference organizers for putting this event together, for allowing me to moderate this session, and for identifying such a stellar group of panelists today. Together, we're all really looking forward to a lively discussion about possibilities and new frontiers in our industry. So I'll get started with some brief introductions before we really dive in. We'll start out with Suzanne Bricker, who's joining us from NOAA, where she's worked since 1990. Suzanne's been working in the marine science world since her days in undergraduate and graduate school. She led the development of the assessment of estuarine trophic status model, otherwise known as the assets model, and that's been used worldwide to assess eutrophication status. She's worked to evaluate the potential for oysters and clams to remove nutrients from coastal waters. And that critical research, coupled with efforts from many other collaborators, has contributed to the approval of harvested oyster tissue as a nutrient management program in our region. And hopefully we'll get to dive into that a little bit more later. Suzanne helped to develop the farm aquaculture resource management model, otherwise known as the FARM model. And that helps to estimate production and environmental impacts from shellfish aquaculture. And again, we'll get more into that later. Suzanne's work has been highly collaborative in nature, working with industry members, environmental managers, ecologists, modelers, you name it. Suzanne's work puts her in the cross-cutting area where science, policy, and management intersect. And now next up is Ted Cooney, who joins us from Madhouse Oysters, bringing his perspective from the private aquaculture industry. Ted's background is a whirlwind and may inspire just a little bit of wanderlust during these largely stationary times that we all find ourselves in. Ted's a Marylander, but he's been around the world and back in his journey to oyster aquaculture. From his undergraduate work at the University of Maine, Ted went on to spend time working in aquaculture in Africa for a few years, then on up to Alaska to put in the grunt work on commercial fishing boats. After that, he headed back across the pond to spend some time learning boat building in England, and then finally made his way back stateside to the eastern shore of Maryland, where he continued working on boats. Sometime in there, he managed to also start a healthcare financial services company. So needless to say, he's been busy. Ted started Madhouse Oysters in 2012. And since then, he and his excellent partners have grown. They've remained curious as to where the research is heading, and they're always looking for new ideas and opportunities to increase efficiency. Ted's also been awarded a number of University of Maryland Industrial Partnerships Programs grants. These are otherwise known as MIPS grants. And that actually brings us to our next panelist, Ronnie Gist. So Ronnie joins us from that University of Maryland Industrial Partnerships Program, again, otherwise known as MIPS. And MIPS is a part of the Maryland Technology Enterprise Institute, otherwise known as MTech. He's been with them since 2008, and he has served as the Associate Director since 2014. Now, Ronnie will talk more about this program, but MIPS is a really special opportunity that we have here in Maryland. That value of collaboration between public institutions and private companies is inherently recognized within this program, bringing together industry members who have a great idea and connecting them with resources and academics so that they can work together on experimentation, design, and implementation. Now, oyster farming is not the only industry that MIPS works with, but it's what we'll focus on today. And in this role, Ronnie has been working to connect companies with faculty researchers to develop novel advances to production challenges. He's worked with a wide variety of companies and researchers, facilitating collaborative projects that lead to the advancement of new technologies and that have positioned Maryland in a leading role for driving innovation and progress forward. And that brings us to our final panelist, who we've already heard from once today. Last, but certainly not least, is my colleague, Don Webster. Don is a senior agent and regional specialist with the University of Maryland Extension, where he's worked on aquaculture-related issues for decades. Don has seen aquaculture in our state through the years as the species, the techniques, and the policies have changed along the way. I'll add that his memory is a steel trap, and that's a good thing because he's learned a lot over the years from our industry here in Maryland to perspectives that he's brought back from time he's spent working with seafood industries across the nation. He works closely with growers and resource managers, and he's worked to bring educational resources to the industry, guiding and facilitating profitable seafood businesses in our state. Over a decade ago, Don worked with a team of colleagues to help revise Maryland's leasing program, as he mentioned earlier, effectively expanding the viability of private shellfish production in our state. Don has seen this industry through the years, and he has stayed the course, and he's always held on to an ambitious vision about where we can go. So now that we all know each other, why are we here talking about technology and innovation, right? They're oysters, toss them in the water, they grow, easy peasy, right? We're done. Well, as I'm sure you all already know because you're here, not so much. That's actually not correct, and it's certainly not correct if you want to make any money doing it. Farming is complex. We're working with living organisms, which is a challenge. Working in a changing environment that can be downright hostile at times between storms, ice, extreme heat in the summer. It can be really, really challenging. And as we talked about a bit in the previous session, these farmers have to constantly respond to the changing preferences of the consumer, and consumer demand is really tough to predict, now more so than ever. And so all of this requires farmers to grow and to adapt. So we're here today to talk about some of the technological innovations that are helping these farmers to grow their businesses. This industry has been moving forward quickly, and there's a lot of room for research and innovation, and all of this is accomplished through really strong partnerships. In my opinion, we've got a good thing going on here in Maryland. We have growers who are happy to have researchers come out onto their farms. We have a deep pool of academic expertise in our state to draw from engineers to geneticists, biochemists to ecologists. We have a powerhouse of academic expertise to draw from, and they're eager to get out with oyster growers to best support the industry. And again, we've got that critical support of the growers with a range of backgrounds who provide their boots on deck experience and ensure that these lab-based results and new technologies are feasible and scalable in their commercial operations. So today we will divide our discussion into three general topics. First, we'll talk about technology as applied to the production and operation of oyster farms, from selecting nursery and grow out gear to optimizing harvest mechanisms. Growers have a lot of options to consider. And next, we'll move on to farm management and monitoring. So I can hold 1 million oyster larvae in my hand, but those same million larvae grow to truckloads worth of product in a really short amount of time. So this partially becomes an issue of materials handling. How can growers manage their farms and keep track of all of that inventory? And how is the presence of that farm affecting the local water body? And then finally, we'll talk about how new technologies can drive efficiencies at commercial scale. Because at the end of the day, these businesses have to make money in order to grow, to support local supply chains, to drive an economic engine in their communities, help the environment, all these things that we love about shellfish aquaculture. The businesses have to be profitable in order to grow. So how might technology be used to help growers achieve scalable efficiencies? So as we move into the panel discussion, the same with the last session, I'll ask that you please enter your questions using the Q&A function as we go. You don't have to wait until the end to enter your question there. Just enter the questions in the Q&A function as you think of them. If your question is for a particular presenter, please go ahead and include their name in your question as well. All right, so like I said, we're going to start out, we're going to talk about operations and production. These growers have a lot of options to consider. So I'd like to start out with some industry perspective, and for that, we're going to look to Ted. So Ted, can you tell us about Madhouse and how your operations practices have evolved over the years?
Sure. Yeah, we've evolved a lot. Just a short story on the front side here. The name of the company came from the fact that we felt like we weren't evolving fast enough, and that's where we thought we'd end up. But you know, just to begin, very first year, you know, it was typical to use floating up wellers for nursery stock once it had gotten to about 1/4 inch in size. Floating dock essentially outside of our building. And in our case, the water was very shallow around the building. Certain times of day, those floats would be sitting on the bottom. The pumps would start cavitating. The electricity bill went through the roof. We're burning up pumps. And then every time somebody came up the harbor and made waves, we were washing product out the exit tube on the pump, you know, on the dock. And so it became obvious that that wasn't workable for us. So we developed a new way to utilize the Australian SEPA baskets, floating them in the water. It eliminated pumps altogether. We were fortunate enough to be able to walk between the baskets and harvest in that way, or at least, you know, change out the baskets in that way. So that made a huge difference in just over the first year, or for the second season, I guess. The first season we struggled through with how we started. And then, you know, developing methods from that point to say, okay, if we wanted to expand the use of this style of basket out into water where we couldn't walk, how would we do that? So then we altered the gear on the boat to be able to bring those baskets aboard without walking in the water. So you expand the use of them to areas where not only do you have more space to use the baskets, but you're also getting away from those NIMBY issues along the shoreline where your neighbors don't want to see, you know, 1,000 buoys right outside their door, because it's a fairly intensive growth method using those lines. And so, you know, you find ways to overcome issues in that way. We changed from using screens inside where we set larvae to using the vertical tubes. You know, I was so surprised to see that an oyster can be flipping around inside of a tube and still have a desire to eat. Actually, I would never want to do that in that environment, but oysters grow 3 times faster in those tubes flipping around in there than they do sitting on a screen. So that was another change that we made to, you know, grow the oysters faster and get them out of the nursery quicker, but also to save us on a lot of labor doing the grow out on screens in downwellers in the building. And, you know, it just goes on from there. You find ways that, you know, if this hurts your back, then find a way to not do that. If that takes you 10 hours, you know, using a box with a screen in the bottom to sort your oysters, shaking them in the water. I used to spend many weekends, you know, brutalizing my kids in the early years, sorting oysters. And then we found a machine that, you know, has industrial uses, sorting powders, things like that. And also rocks in a quarry. we started sorting our oysters with one of those, and it just, you know, changed our world dramatically, one thing at a time.
Excellent. Thanks, Ted. So yeah, it sounds like it's been a constant adaptive management challenge. It seems like always responding to one issue and trying to be proactive and moving towards the next. So some of that makes me think about the MIPS program that I mentioned earlier in Ronnie's introduction. And so Ronnie, I wonder if you can tell us a little bit more about what is MIPS, and if you have any cool examples of funded projects that have been aimed at production challenges for farmers. We'd love to hear about them.
Sure, happy to. And thank you, Shannon. Thanks for everyone for attending. MIPS for short, Maryland Industrial Partnerships, has been around since 1987, continuously funded by the state of Maryland. It's a grant program that funds research and development, anything really. It's one of these things that you tell companies and folks, you can do anything you need to do as long as there's a professor, faculty member, extension agent, someone in the university system of Maryland that has the expertise you need and is interested in working on the project with you, right? And I do absolutely have some examples. Some real quick numbers about MIPS. Folks always want to know, what are the grants, how much? The typical grant is a $100,000 project for startup companies, per project per year for up to 2 years. So a startup company, which almost every oyster company will qualify in Maryland as a startup because we have very relaxed rules about that, right? 20 employees, less than 2 million in revenue. We could go into other categories, but for startups, it's a 10% match, cash match. So you have to have your skin in the game, but MIPS pays 90%. So the numbers are a $100,000 project, MIPS pays 90, company pays 10 for up to 2 years per project. And there's no statute of limitations. So as Ted knows, with his company, he is now on his third MIPS for different projects, right? Continuation related to what he's doing. And his is one of the best examples I would first give, and I won't share too many details because, you know, this is always proprietary to the companies. But part of the big problem with oyster processing is you pretty much need a land-based operation. You got to have a walk-in cooler because there's so many requirements about getting those oysters chilled and refrigerated, right? So Ted has this concept and idea that he thought of for years about how can I do this out on the oyster leases, out maybe way out in the bay, way up the creeks, way away from any land-based facility, and still be able to do it efficiently. And by the time I come back to my dock, and it doesn't have to be a land-based walk-in, I can offload boxed oysters ready to go on the refrigerator truck and go. And so that's one project that's and there's a few related ones that Ted knows well that we're still underway, a couple of those, right? So that's one. Another one I thought would really fit well in this category, and I won't, again, share the company names at the moment, but anybody that wants to know about this, I'd be happy to talk to them, email me, and we can even get with the company, because almost all you folks, I'm sure a lot of the folks are on this conference today watching, but one of those was a spat on shell operation. So for wild caught oysters, but obviously you're always starting with the spat on shell. That is really, talk about labor intensive and breaking your back. At the volumes that most oyster growers can do or want to try to do on a land-based site, it's inefficient and backbreaking, right? So this project is one that was done where it's semi-automated, you might say, where the spat on shell operation is being done on land, in tanks, running the seawater through, watching the conditions and so on and so forth, and then getting the oysters set, getting them on a barge that was also funded by MIPS, to the changeover and outfit of that barge and boat, and out to the oyster grounds and getting them out on the oyster bed. So those are two real quick projects that I think were in this category. I want to just say, if I can, this is probably a good point to tell you that I totaled up all the oyster-based projects that MIPS has done and in our history, and some went really far back, like mid-90s. There were aquaculture oyster projects, some of which Don, I'm sure, would remember, because that's before my time there. And we've done 18 specific oyster projects, some 1 year, some 2 year, with 12 different Maryland oyster companies. And I should mention that this program is for Maryland companies to add jobs, increase revenue in the state. So that's my quick one. Hopefully that was quick enough.
That's great. Thanks for sharing, Ronnie. That's impressive. 18 oyster projects and 12 different companies. Those are some good numbers. Well, now I'd like to bring in Suzanne. I'd like to turn it over to Suzanne Bricker. And Suzanne, I'm wondering if you can talk with us a little bit about the farm model, explain what goes into it, and how that might be applied to shellfish production, whether it's siting, planning, whatever. You take it. You know it better than I do.
Okay, so I want to try to share a slide that is a schematic of share. Okay, so what we've tried to do with the farm aquaculture resource management model, which is what you see here, is, and I should add that ours isn't the only model, but this is the one that we use, that we developed. And it's a tool to help evaluate differences in harvest that result from different aquaculture practices. So model inputs can be changed. And what you see here is the water moving from the left to the right across an oyster bed. The chlorophyll A is a pigment that we use to help estimate phytoplankton, which is food for the oysters. They also eat detritus, which is partially digestible, and then dissolved oxygen. So those are a few of the more important inputs to the model, in addition to farming practices. So the model inputs can be changed. For example, seeding density, whether diploid or triploid oysters are being used. Also, we can change conditions. So one of the things that is of great interest is changes, and especially drops in salinity. So we can make all these changes to the model, run the model, and then look at what those different scenarios will produce. So what's the harvest that we produced based on the different aquaculture practices or different environmental conditions. And the whole idea is to look at possibilities for farms and to evaluate how to get optimal production while minimizing water quality damage. So Matt Parker and I actually applied this model to several Maryland oyster farms, and I would like to send a big thank you to the growers who participated in that for being so generous. So we were looking at the range of Maryland harvest based on the range of aquaculture practices. Both bottom and cage grown were included in our project. And so maybe a good question to ask is, how well does this model do with simulating the harvest based on what you see? And someone said proprietary a little earlier. And so we realized that harvest numbers are private, but we were able to get one grower to provide harvest numbers. And we were within about 10 or 15% of the observed harvest. That matches up with our success of simulating in other places where we've done this work. So I would invite anybody who is interested to contact me if they want to try the model. We need, as I said, the environmental drivers, but also we would need your aquaculture practices, and then we would plug those into the model, but we can also change those and see how your operation might change given different seeding densities, etc. And I might be getting a little bit ahead of the program because there is a nutrient crediting session after lunch. I hope you'll tune in. But we've also used this model to evaluate the associated nutrient removal. And that can be used to apply for nutrient credits in the Maryland Nutrient Credit Trading Program. Now, it's important to remember for right now that those are based on harvested oysters and the size of the oysters, but we're hopeful that this model could give another way to estimate that in the future. So thanks everybody for your attendance, and I'd be happy to answer any questions. And I want to give you back the, oh, stop share. Okay, there you go.
Perfect, perfect. Thank you, Suzanne. I didn't realize that the model had predicted within 10 to 15% of the observed harvest. That is impressive. And I think we'll be sharing all of the panelists' contact information at the end. So if folks would like to get in touch with Suzanne, they can certainly do that. Now I want to turn it over to Don. Don, I hear you've got an idea and you want to toss R2-D2 in the water and tell him to get to work. So can you tell us about this new opportunity and a new project going on using robotics?
Thank you, Shannon. It's a pleasure to be here with you and my friends Ted and Ronnie and Suzanne. This conference has been going really well so far. Yeah, I want to pull this up, see if I can share this properly. What I want to run through is the S3AM, or the Smart Sustainable Shellfish Aquaculture Management Project I've been involved with the University of Maryland Robotics Center. Let me preface this by saying what Ted was talking about and what most of the growers previous to him are using water column leases. These are ones where they raise high quality half shell oysters specifically for raw bars and restaurants. Maryland does have quite a few of the water column leases now after our lease revision, but we still have more acreage and number of leases in our traditional bottom culture, in which you prepare essentially barren bottom with a foundation of traditionally oyster shell and then plant spat-on shell with hatchery larvae over that. This is where we're looking at this S3AM project to focus right now. You can't be interested in modern agriculture without being impressed with where it's gone with breeding, selection, genetics, a lot of the technology, drone surveying of fields now so you don't have to walk them, and much more efficient. There's agricultural equipment now that can be operated from miles away. And we are decades, if not a century, away from that in a lot of the oyster culture technology. In December 2018, I was asked to provide information on aquaculture at a faculty retreat for the Maryland Robotics Center of our engineering college. And it was a very, very interesting discussion with those folks. And from that, we created a working group to look at needs in the industry and try to develop technology for it. Over the following year, we actually brought a group out from the Robotics Center. Went out with several of our growers, Bobby Leonard down there in the bottom left on some of his leases, used underwater drones to take photographs of the shellfish leases. And then the faculty went back and looked at how, beginning start of how do you use this information to distinguish live oysters from shells? Very difficult dealing with sediment here in the bay. And they've actually done a good job in trying to create some of the early technology to be able to do this and better able to manage oysters on the bottom. Currently, we either use patent-tomes to sample or divers, and diver surveys with quadrats is very time-consuming and expensive. Well, what happened with that was we put together a very nice group of folks from all coasts of the United States, sat down, put together some proposals. And we were notified this summer that the U.S. Department of Agriculture has funded a 5-year, $10 million project to develop robotic technology for enhanced bottom lease production. Trying to bring that technology into farming. Ultimately, if we can increase production, into processing and marketing for large-scale distribution. To emulate modern agriculture with computerized planting and harvesting, as well as monitoring and processing. And then to partner with our colleagues in the Northeast, Mid-Atlantic, Gulf, and Pacific Northwest to test and implement the equipment that's developed through the project. Basically, this is growing our 21st century industry. These are the long-term goals. Actually, Objective 5 in the middle is already to start with creating a national advisory board of industry, research, and extension colleagues on all these coasts. Using the drone-based environmental and crop monitoring, create smart harvesting equipment and farm management tools for farmers. That will then be done both in the laboratories initially and then taken out for field trials around the coast. Strong economic assessment in that with Matt Parker and Jonathan Van Senten at Virginia Tech. And the other part that's really interesting is we have a very strong knowledge portion of the program that runs from 4-H right up through undergraduates and summer research fellows. So we're really looking for this to be a great project with some really, hopefully, very strong progress in the future. You can see the logo that they've created down there with research, extension, and education, and locations around the coast. These are some of the faculty that have been involved with this so far. Robotics faculty up the top, including University of Maryland Center for Environmental Science, Pacific Shellfish Institute, Louisiana State University, Virginia Tech, and then our colleagues in 4-H and working with education. So we're really looking forward to this being a great project in the future.
Thanks for sharing, Don. I'm also really looking forward to seeing where that research goes, and interesting to hear that that's a technology that can be used both for the operations, the production, the harvest, but then also I heard you touch on managing that crop as it's growing. And so I think that brings us nicely into the next topic up for discussion here. And for that, I'd like to turn it back to Ted to talk a little bit more about inventory management. How do you keep track of all of those oysters, especially as your farm's growing, and so you have oysters at all different sizes and different ages? How do you keep track of it all?
Thanks, Shannon. Yeah, sort of running through the history. I initially kept track of everything that I put in the water on a Excel spreadsheet, which, kind of necessitates coming home at the end of the day when you're trashed and tired and sitting down at the computer to do some tedious work for an hour or so at least. Changing dates, moving things around, making sure you're up to date so you know how long things have been sitting in various containers and when they expect to be moved. Over time, that becomes cumbersome, and you realize, as you scratch along, that a lot of people in the industry are using whiteboards, and they're just making a couple notations on those boards at the end of the day or during the day in the building, and that does a credible job as well. As a matter of fact, it's probably one of the best ways of doing it for some period of time. As long as you can keep track of it, it's great. As long as you don't have a disgruntled employee who erases it on the way out the door, then you're going to be fine for the most part. But then, you get a little bigger, you start getting hundreds and hundreds of cages. You have larvae you're working with maybe, or all sorts of different containers on land for the tanks and things like that. It becomes far more efficient to find a piece of software that does the job well. And one of the things I've done in a previous life was software development for a few years. So I recognize that it's not something that you put some money into and then it's finished. Software development never ends. So if you're going to get into software development, you have to have a fairly unlimited source of funds to continue developing into the future. So I didn't want to develop my own Oyster software. That didn't make any sense. I looked around, saw one product out of Australia back a few years ago that seemed to be sufficiently old that if you bought it, they would send it to you on a floppy disk. So I figured, okay, if they're not keeping up, then that's going to be more problem than it's worth. And kind of a plug here for Oyster Tracker. That's what we use now. And full disclosure, I don't use it. The guys that are on the boat, my partners Scott and Scotty, they use it on a daily basis. They can update it while they're on the boat. They can keep things in order so that when they go home at the end of the day, they can go home at the end of the day and spend time with their families. And Chip and the team at Oyster Tracker have been phenomenal partners in the industry because, having had that little bit of experience in development of products like that, I was amazed to see him actually come to my farm a number of times, ask how we were using it, ask what we wanted it to do that it didn't do, and was talking to people all over the place. Also knowing that, you know, if he sold to every farmer on the planet, he wasn't going to become Steve Jobs. It's just not that big an industry that the man's going to end up driving a Bugatti because he's developed this product. He did it for the love of the industry and because he could. And that sort of attachment to the development of what is his business in our industry has been the reason that it's been pretty successful. They've now gotten additional funding that will take them forward into the next few years. They continue to be really actively engaged with the farmers that are using it to find out what it still doesn't do that we would like it to do. It's very easy to use, and you know, our cell phone signals on the water are awful where we live, but that doesn't mean we can't update things on an intermittent basis when we have a chance during the day, and so it works in that environment. And now we've gotten to the point where they have the ability to print out harvest tags. So that's another thing. Instead of your customer, your wholesaler getting some chicken scratch on the tag that maybe bled while it was in the box on the way there, they're getting a pre-printed tag that makes us look a little bit more professional than we did in the past. And we can keep records of that. And there's just a whole lot of things that go with somebody out there developing the product that is useful for the industry and working with a bunch of different types of gear and making it so that we understand it in our world, whereas maybe a guy using different type of gear and using different terminology for his gear would still feel at home with that product. So that's been a great thing to have somebody else take the ball and run forward with it on our behalf, really, and take something off of our plate that, you know, we have no business doing anyway.
Yeah, it sounds like a nice blend of bringing some appropriate tech onto the boat in a way that's really, really helpful in terms of both monitoring your inventory, but you know, you also touched on printing out those harvest tags and making those look really professional and clear. And as we talked about in the previous session, it's ever more important for farmers to, you know, be establishing themselves with suppliers and developing those really, really good relationships. And so anything to be reliable and professional seems like a boom. Now I want to turn now to Suzanne to talk about a different side of management and monitoring, right? So in addition to monitoring the crop and how that's growing, many of our farmers also want to monitor the effect on the local environment, and indeed some buyers require that. So Suzanne, can you talk to us about monitoring both in the water and in the benthic environment?
Yeah, so I will say right now that I have less experience with monitoring the benthic environment if you're talking about taking sediment samples. But we do monitor dissolved oxygen, which can tell you about the conditions. And so I would say shellfish growers the oyster growers that we worked with, were concerned with temperature and salinity. And those, well, not only, but those two things are fairly easy to measure. And for example, they can do that, and some of them were doing that themselves using a refractometer, which is I think maybe $100. Temperature by a thermometer, not so expensive. But when you look at wanting to measure dissolved oxygen, then you're talking about a little bit of a greater expense. I think probes are anywhere from $300 to $1,200. So, but the growers can do that themselves on site. Chlorophyll A, or the measure of phytoplankton, the measure of nutrient concentrations, which you might want to know about it, particularly ammonia, if you're overpopulating your site, particulates, those things can be collected at the site, but do have to be sent to the lab then to be analyzed. And so Matt Parker and I went to, as I was saying, several Maryland oyster farms, and learned that each lab sample to do those analyses costs maybe $50, $55. I don't know if it's increased. Just to give you a rough measure, we went monthly. So, but that also could be done, the sample collection at the farm by the grower. However, a less expensive option might be to use the already being collected Maryland Department of Natural Resources Eyes on the Bay data. They collect all those data once a month at 100 tidal stations in the Bay. And so if they could find a close Maryland DNR sample location, they could actually get a fairly decent idea of what their site looked like as well. The caveat to that would be that you would want it to be within the same water mass. So for example, if your farm is in a cove that isn't well flushed and the closest station to you is in a place that is well flushed, that wouldn't work very well. But we're doing a small project that's doing exactly that, looking at a comparison at 2 sites, one in Chester River and one in Hunger River, with the closest Maryland DNR monitoring stations. Those are 8 kilometers away in each case. And what we've discovered is that there's no significant difference in the water quality variables that we're interested in to run the farm model that we were just talking about. There's no significant difference. And so that was really wonderful for us to learn. And I would encourage growers who are interested in looking at the water quality at their sites. At least we know within 8 kilometers, we don't know how far that would extend, but for now, we're very optimistic that those Maryland DNR sites, and the data are for free, can be downloaded for free. I've been doing it for years, and I just want to say a big thank you to the DNR folks, because they've always cheerfully handed over their data. And so I would recommend that to growers who are interested in more than just looking at temperature and salinity. So that would be my recommendation.
Thanks for that, Suzanne. Always nice to hear about an existing data set that's out there that's accurate and also free to access. That's fantastic. Thank you for sharing. Now I'd like to move into our last topic before we get into some questions from the audience. So now I'd like to talk about using technology and innovation and how this can drive efficiencies at a commercial scale, right? It's different to do things in the lab or on a small, maybe a 1 acre little plot, but it's very different to achieve efficiencies at a commercial scale. And so I'd like to start out, and we'll toss it back over to Ted to see any farm alterations that you've made that you feel like have really driven some efficiencies for you that are really worth their bang for the buck.
Sure. Well, the one I already mentioned, and that was changing over to the use of the baskets in the near shore nursery area, just eliminated the electricity cost for those small oysters near the building. So that was one. The next probably biggest increase in efficiency for us is we used bottom cages. And for the first year, I was lifting those, one at a time into a 21-foot Carolina skiff, dealing with them, pick up 6 cages a day, literally, drive them back to my building, tumble them in the building. That turns into 10 or 12 cages. And then maybe you have enough time to go set them, but you have to take 2 trips because you can't fit that many on the boat when they're full. So that sort of level where I was, perhaps doing 6 cages a day, to the point where the following year we developed a floating platform, essentially a barge, put the tumbler on it, developed a hydraulic lifting mechanism to get them out of the water quickly and easily without breaking your back. And we were, the next year we were doing 25 to 30 cages a day, which turned into another 30 cages a day. We had days where we were able to touch 75 or 80 cages in a day. So when you start being able to do that with 3 or 4 people on a boat, then you can start achieving the labor efficiencies that are possible to actually get beyond minimum wage for all the people on the farm. Of course, you throw in a rain event or a pandemic, and that throws all that into the toilet. But we're still hopeful that eventually we're going to have enough years strung together here where we can actually achieve what I think is possible in this industry. There's a lot of it that, you know, I don't want to say we're in the Stone Age, we're not. It's developing quickly, but it's fun to be in an industry where you can dream up a piece of equipment that you could really use that doesn't exist. And so you start inventing. And then Ronnie and the people like that are out there with MIPS programs and whatnot can help you get it developed beyond what's in your brain. And so that's kind of where we are, is we've got, you know, 2-3 pieces of equipment now that we haven't put into commercial sale yet, but which are already making a difference on our farm. And the biggest difference is that you have people that love this industry that want to work in it, but who recognize after a couple of years that it's ruining their health because it's so difficult physically to continue. So if you want people to be able to do this for decades as a career, you need to be able to provide an environment where they can do it without ruining their health. And so that's where we're heading, one little step at a time.
Thanks, Ted. Yeah, and those logistics are really, really important. And you touched on this, and I think this is a great time to turn it back over to Ronnie. Ronnie, you and MIPS are really at the center, at the heart here of some of these innovations moving forward in our state. Any others you want to share with us that are really driving some efficiencies at scale?
Sure, yes, love to. Suzanne reminded me, I want to give a shout out also to the DNR, because of those 18 oyster projects I mentioned, DNR has funded 10 of them in the last 10 years, basically, right? And that's that's through their program called the Innovative Technology Fund. And what that does is MIPS has money from the state every year for any technology, any science. So it doesn't have to have anything to do with aquaculture, right? We do everything, projects for the medical school, all kinds of other engineering, science-based projects for companies. But DNR funds projects that specifically improve water quality in the bay, and more specifically by nitrogen, phosphorus reduction, sediment reduction. And so oyster-based projects that are demonstrated to put more oysters in the water have the potential of helping a company grow so they are putting more oysters in the bay. They have funded many of those, and including the ones that I mentioned of Ted's. But specifically, there are so many. You could make an argument that efficiency and production management is improved with almost any of these that we have, but the two I thought would be most interesting, one that's underway now, two of them actually still underway now, is basically, if you can envision a floating platform, self-powered, out in the bay, so it can be just about anywhere. Have to worry about navigation hazards, obviously, right? But if it's where an oyster lease is, that's typically not anywhere near a navigation channel. And the idea is it's self-powered and self-rotates the oysters using solar energy to store battery power to cull and rotate the oysters. And that's one that's underway right now. And the economies of scale there and the volume of oysters you could possibly do would be amazing, given that you get this thing completely working. So that's an early stage project that's underway now. And another one that is real interesting is, you picture a vessel that is doing some amount of oyster processing, inventory management also in the future, that is basically a water vessel equivalent of an unmanned aircraft. Okay, so basically it's an unmanned vessel that's going to go out on an oyster farm. So it would be a designated area that it could work in, but it's basically going to work, if not totally by itself, with a much reduced employee load and a much higher efficiency. So those are two that are underway now, funded by MIPS. And I just like to say quickly that the whole beauty of MIPS is, if you are an oyster company or farmer out there and you have an idea, or more than an idea, something you've worked on already, begun to develop, begun to design, you need to build it out, test it, that's what MIPS is for. That's the whole idea behind it. So please contact me, because DNR is always looking for projects to fund. And the beauty of that is your odds of winning an award are far greater if DNR wants to fund it, right? Because you're not in the pool of all the other MIPS applicants.
Thanks, Ronnie. One of the things that Ronnie was just chatting about in terms of the projects that are funded is that DNR and our state are really interested in reducing nitrogen, phosphorus, a lot of the nutrients that are ending up in our coastal waterways. And so we have a session on this later this afternoon, but I did want to toss it over to Suzanne to just speak briefly. I know we're coming short on time, but to just speak briefly about maybe a new opportunity for growers to make a little bit of extra money.
Okay, I'm going to share another slide right now, and okay, oops. And there we go. So, so this is actually one of the really interesting and exciting concepts that has gained momentum in the past few years, and that is because oysters and bivalve shellfish filter the water, they remove particulates, phytoplankton, but also detritus, and so essentially they clean the water. And the second part of that is that service, that ecosystem service of water cleaning, and here we're talking mostly about nutrients, actually has an economic value that may actually transfer to the growers. And so what I'm showing you here is what was mentioned earlier. The Chesapeake Bay program has approved harvested oyster tissue only, but to receive nutrient best management practice credits. And just going down, looking at the pink lines, diploid oysters of 3-inch size, which is the typical harvestable size, not the only harvestable size, but typical. If you harvest 1 million of those oysters, then you can be credited with taking out of the water 198 pounds of nitrogen and 22 pounds of phosphorus. And then you can look at the same thing for triploids, which actually take a little bit more nitrogen out. So, but there are two parts to this whole idea. One is that you have to get the credit. And so the Maryland DNR, I think, does the certification and the crediting. And so that's really exciting because those can now be used to fulfill legally mandated nutrient reductions in water bodies that have total maximum daily load requirements. So they're required to reduce a certain amount. You can now use oysters to do that in the Chesapeake region, which is actually really, really exciting because it also then hopefully will expand the aquaculture business. But the second part of that, the payment for services, is a little bit more complicated. And the reason for that is the price. How do you determine a price for the credit? Typically, the market will determine that. We know that 2 Maryland growers were recently paid for that service. The Baltimore Convention Center made a voluntary payment to show and to highlight the dedication and support of water quality improvement through oyster aquaculture, which is really, really cool. The other payment was a best management practice offset to offset nutrients from stormwater to fill a required reduction in Anne Arundel County. So this is actually really terrific progress towards the recognition of other ways that oysters can be used besides just eating them. But will nutrient credits increase grower profits? Matt Parker has done an analysis using a specific value of a credit. And what he showed in his analysis is that no, and it won't actually make or break, but there's no significant increase in profitability. Having said that, it really will develop on, really will depend on the cost, the value of that credit. And so I would say stay tuned. For now, there's some question. I would also say to remember that in order to get credits, you have to harvest the oysters. And in times like this for COVID, where we already heard that harvest is not what it used to be, you know, the profits from the credits, in addition to revenue you're getting for your product, can be quite uncertain. But stay tuned. I think there's a lot better discussion of this in the session after lunch. So thanks a lot for listening, for being part of this discussion. Thanks, Shannon. Thanks everybody on the panel. And I'll now stop sharing and send it back to you.
All right, thanks, Suzanne. So I'm looking at the time here. We do have some good questions coming in through the Q&A. So I think we'll go ahead and open it up to some of these questions we're seeing from the audience. So the first one is from Scott Budden. Scott says, being in an ever-evolving industry is great from the standpoint of innovation and DIY ingenuity, but how does a grower confidently make vast investments in gear types when they could be antiquated in a matter of years? Swapping ton cages is one thing, but converting 1,000 is totally different. So I wonder if, Ted, I don't know if you would want to take this and share your perspectives on your farm's evolution in terms of gear.
Sure. Yeah, Scott, you're a fellow traveler, so I know that you understand how difficult this can be, and swapping gear types is a very expensive proposition. So what we tried to do was, you know, if something was clearly needing to be abandoned, like our first initial work in the nursery, then, you know, you bite the bullet and you do what you need to do. But as I went further along in my business, I tried to make sure that my innovations allowed me to expand the type of gear that I was able to use rather than swap and abandon. The big boat that we use now out on the water can work bottom cages or SEPAs or floating cages, all within the same day, all within the same hour with equal facility. So we don't have to get rid of equipment to use a different type of gear to hold the oysters. And it's difficult, but if you're, you know, if you have a platform rather than a skiff, then you have the opportunity to think through some of those changes in a way that allows you to, okay, we don't want to stop doing this, but we want to do that. What can we do to make that possible? And, you know, I've done this for years, and I'm happy to take anybody down and show them our boat. So call me afterwards and we'll figure that out.
Sounds great. Thanks, Ted. Another question that came in here from Benjamin Ford. It says, is there a technological or efficiency concept that is proving elusive or challenging, but would be really useful for either the aquaculture industry, water quality, or nutrient trading? And for this one, you know, Don, you've got a lot of experience in this industry. What do you think? Is there anything that's proven especially challenging, and what would you be really excited to see enter this industry to move it forward?
I think, Shannon, well, there are a lot of things that are needed out here, which is one of the reasons why we started talking with the engineers. I got in a discussion with one of my growers recently and said, harvesting is just abysmal right now. We're still using oyster dredges. And he said, well, that's actually a pretty good piece of equipment. I said, I've been to your home. You don't have an outhouse for sanitary purposes. Your wife doesn't have a hand pump in the kitchen, and she's not cooking on a wood stove. That's 1830s technology. That's when the dredge arrived here. Said, you know, using this 3.5-foot wide Maryland oyster dredge and pulled by a 300 or 400 horsepower boat is like planting the wheat fields of Kansas with walk-behind rototillers. We have to do better, and we know two things. That dredge kills small oysters and tears up bottom sediment. There is a lot of technology. Some of the robotics we looked at to start on the bottom culture, but you know, you can push this to the future. A lot of labor involved with the with keeping the cages clean, as you well know, Shannon, from having done a lot of this work. Why can't you have robots that can go out there, clean that gear, and perhaps sort the oysters on the ground? I think we're just at the beginning of where a lot of this advanced technology could go to increase output and cut operating.
Yeah, it'll be really exciting to see how we can make these operations more efficient, cut back on some of those logistical challenges. Well, look, we've got just 2 minutes left, and I'm sure everybody's getting ready for lunch, but we've got another question here that I think we could perhaps chat through pretty quickly in a rapid fire. Can we talk about flip cages? Seems like everything's coming out of Australia, but any experience with floating cages and those flippable floating cages? Either Ted or Ronnie, do either one of you want to take this?
We've not had anything that specific about it, about cage design itself. A couple of the projects have had, redesign of cages so that you could attach them together more efficiently and cull the oysters out of them more efficiently, but nothing specific to that.
All right. Well, it sounds like there's room for more opportunity. Or Ted, were you going to jump in?
No, just that the one, these things are constantly evolving and getting better. Somebody makes a new floating cage, and then the next guy who comes along says, that's a great cage, but if it had just this thing, then it would be even better. And that's what's happening. And one of the great changes that I've seen that is really useful is the ability to remove the floats and let the cage sink to the bottom for the winter, but it has legs on it. So it's not going straight to the bottom and then causing the oysters that are in the bags to die. So that was a nice change that allowed those type of floating cages to do their magic in the summer, but not be a liability when the weather got bad.
Got it. Yeah, I know all too well about some of the challenges that come with those floating cages sinking. Well, with that, I know there are more questions, and there's certainly more that we could chat about with this panel, with the expertise housed in the screen right now, but we are butting up against the end of the session, so I'll turn it back over to Allison.
Thank you, Shannon, and thank you everyone on our technology and innovation panel.